Alright, so I'm going to do a continuation of yesterday's problem, and I'll review what it was. It says, excuse me, the table below gives the shipping price for different numbers of soccer balls. Do the numbers in the table represent a proportional relationship, also known as a direct variation on the algebra side of things? And to check that, we took our y variable and divided it by our x variable. And if we got the same number every single time, that meant it was a proportional relationship, and that number that we got is called the constant of variation. Okay, so now we're going to add one more element. Okay, now that we've decided that it's a proportional relationship, we're going to write a direct variation equation for it. Okay, we haven't written equations yet, so maybe this is really exciting for you guys, but I'm going to change color quick. So to write an equation for it, it's going to have a y equals, this is our dependent variable. Our dependent variable always depends on our independent variable. Our y variable always depends on our x. The price depends on the number of soccer balls that you've purchased. So that makes sense. The price here depends on how many soccer balls you've purchased. So it makes sense that this is the dependent variable, this is the independent variable. All right, there's going to be something with an x over here. And I have to be able to plug my x variable into this equation. So let's just say I have to be able to plug in 1 right here, 1 soccer ball, and I need to be able to get out 2 for y. So I need to do something to this x, whether it's add something, subtract something, multiply or divide, or maybe both. So let's try it. So if I plug in 1 for x right here, all I have is 1 on this side, and I need to get to 2. So I'm just going to say, let's try adding 1. Okay, if I plug in 1 for x, I have 1 plus 1 gives me 2. Hey, it checks out for this one right here. All right, so let's plug in 2 for this one now. 2 for x on this one. I'm going to plug in 2 right here. So I have y equals 2 plus 1. Well, that equals 3, and we need to get out 4. So adding 1 only worked for this case right here. Didn't work for the whole thing, so that means it's not our equation. All right. So another way of getting, if I plugged in 1 right here, another way of getting to 2 is I could just take it 2 times x, right? Or I could go x times 2. Either way it would work. If I plug in 1, I have 2 times 1. 2 times 1 is 2. It checks out. Now let's plug in 2 for my x variable. If I plug in 2, then I have 2 times 2. 2 times 2 is 4. Hey, that works. If I plug in 3 for x, 2 times 3, hey, that works. And if I plug in 4, 2 times 4 is 8. This equation looks like it's our 1. All right, and this is actually what every single direct variation equation looks like. All right, something like this. The general form for a direct variation equation is y equals k times x. Because I'll have you look back and notice how the number here was 2, and our constant of variation was 2, and that's how every direct variation equation looks like. It's y equals our constant of variation times our x variable. So whatever you get for your constant of variation, if it's a proportional relationship, goes right here.